understandable. All right. So yeah, I think that'll be it. So I'm debating. Yeah, I think I'll come back to this a study on this, and I just never motivated myself well enough to do it. Like the decomposition, or really the decline of algebra skills over time since an algebra course. But I don't even know how that would be measurable. It's just it accounts for so much of the credit that you earn in the math classes that follow it. And like I always point this out in my calc classes. Like, look at all the work that we just did. And then I'll be like, there's the calculus in there. Like, I'll show you real quick. Keep messing myself up here. The second property on the sheet here is talking about the sum of the eigenvalues is equal to the trace of A, and the product of the eigenvalues is equal to the determinant of matrix A. All right, so if you know the determinant of a particular matrix, then you know what the product of those eigenvalues are. And if you happen to know what the dimensions are of the original matrix, then you have a sense of how many eigenvalues there could be, how many unique eigenvalues there are. So sometimes, it's not always possible, because if you have fewer eigenvectors than you do rows or columns, then it doesn't necessarily bear out. But it's definitely useful information. All right. So the trace is defined to be the sum of the elements of the main diagonal. All right. So with that piece of information, I now know that the sum from I equals 1 to 3 of lambda sub I is going to be equal to 0 plus 3 plus 5. You could just write 8 though. And the product going from 1 to 3, position 1 to position 3, or column 1 to column 3, row 1 to row 3, it's square, so it doesn't matter. All right, that's a little bit of a different story, because we have to find the determinant. All right, you can do it by hand, or you can do it on the calculator. There's a fair amount of nice numbers here, so maybe you do it by hand. All right, if we do it by hand, I'd be probably most inclined to work with the first row. So 0 is irrelevant. So -1 2 0 0 5, and then plus different color 2 2 3 0 4. Yeah, the only thing that ever prompts me to do something by hand as opposed to on the calculator is just kind of like a risk analysis. I mean, it's not really a risk analysis, but it's like, how long would it take me just to type this in? How long would it take me to write it out? Not much longer to write it out. All right, how long would it take me to physically get my calculator out of my bag? Yeah, like you're starting to do the pros and cons, and before you know it, you've already done it by hand. So negative, we got 10 plus 2 times 8. All right, so we're talking about a total of 6. Now, if this were given as a 2x2 matrix, then I would consider actually using this information to solve for the actual eigenvalues, because then it's really just a matter of setting up an equation, a system of equations and solving it, right? Because I mean, here I have 3 equations with potentially 3 variables, because again, the eigenvalues could be repeats, so that could be a little bit of an issue. But if it were 2x2, I would write one equation as x plus y equals 8, and another where x times y equals 6. sub one into the other and solve, and then I'll have both of my solutions. All right, so that could be a useful application of this because it's a very quick way, especially for 2x2s. It's a very quick way to get a hold of your eigenvalues without having to do much in terms of calculations. Because really, I mean, the process of finding a determinant of 2x2 is nothing, you know, and the process of finding a trace is nothing also. You're just adding down the main diagonal. So you already have those two key elements. It's just a matter of doing a little bit more work beyond that. Right? So, you know, but the reality is you have other methods that you could use to find eigenvalues. So you might say, well, I'm going to opt out of this one. Well, to some extent, yes, unless, you know, I tell you have to do something involving this rule, like determine if it's a true or false, you know, like on the last test. Determine whether the following are true or false, and if it's false, give a counterexample. You know, so I could very easily just say the trace of a matrix is equal to the product of the eigenvalues. You know, just kind of give it backwards. And then you would say false, and then by saying that, you would have to then justify why that's the case. Right? And so it's actually, once you conclude that it's a false statement, it's actually pretty easy to justify it. But, you know, different conversation for a different day. Sorry, I forget these things if I don't remind myself. I turn away for a second, I got like 15 emails. Put true false question related to trace on linear algebra test. Life's easier when I kind of develop the test on the fly in class, because I have the old versions and everything like that, but sometimes I'm looking for like a fresh new problem to put on there, and these moments are good for me. What is this? I don't even know. That I can do. All right.